Okay, so in this video, you are going to solve this question I have on the screen, which says that the cross section of an extruded aluminum channel is shown. Determine the x and y positions of the cross section's centroid. So you have to determine the x and y position of what the cross section's centroid. Okay, so the centroid will be the position, okay, where the area of what this figure is what evenly distributed. So that's what will be what the centroid. Okay, so for this to be easy, first of all, this is the actual question that's given. Okay, this figure here is just to help us solve the question. Okay, so it's actually not part of what the main question. Okay, so looking at this, okay, this length here is given to be what 40 millimeters. Okay, and this small length here is given to be what 10. So when I subtract 10 from 40, that'll give me this length that I have here, which will be what 30 millimeters. Okay, so that's how can we have this 30 millimeters. Okay, it will be very useful to us. It will be very useful to us. Okay, so that's how come they brought it here. Okay, so now that you know how you got this 30 degrees, let's go ahead and then solve the question. So for this to be easy, okay, having a figure like this figure here, okay, is you can find the line of symmetry for this figure, okay, which is the line that can divide this figure into what two equal halves. So let's look at how I'm going to do that. So you see that this is 50 here. Okay, this length is what 50. Okay, so half of it is what 25. So I'm going to draw a line through half of what this 50 here. So this is this line here. So this will be the line of symmetry for this figure here, because it divides this figure into what two equal halves, the same half on the top side and the same half on the downside. So this will be the line of what symmetry. So one easy way to know the position of what the centroid is what to determine the axis of symmetry. And when you're able to get the axis of symmetry for this figure, you should know that the centroid will definitely what be on the axis of what symmetry. So that's one trick for you. So our centroid will have to be on what this line of what symmetry. Okay, our centroid will have to be on what this line of what symmetry. Okay, so let's go ahead and then do it. So you have to find out the x and then the y positions of what this centroid. So what we are going to need is we are going to need the area of this figure here. Okay, you are going to need the total area of this figure here. And for us to get this total area easily, we can find the area for the small rectangles here. You know, I can have this to be one rectangle, this to be one, and then this one here. Okay, so I can have this side to be rectangle 1, rectangle 2, and then rectangle 3. So I'm going to find the area for each of these rectangles and add them. When I add the area of these three rectangles, that'll give me what the total area for this figure here. So let's go ahead. So I'll find the area for the first triangle, which is for this area 1 here. Okay, so A1, this will be equal to this 50 millimeters here, okay, by this small distance, which is what 10. So that's what 50 times 10. So that'll give us 500, okay, millimeter squared. So that's 500 millimeter squared. That's area 1. So let's find for area 2 also. So area 2 will be 30 millimeters by what 8 millimeters. So that's 30 by 8 millimeters. Okay, so let's do this. So 30 by 8. So that gives me 240 millimeters. Okay, that's millimeter squared. So 240 millimeter squared. That's the second area. So let's find for the third area. So for the third area, that will be this 10 millimeter by this 8 millimeter. So we have the same thing as the second area. So that will be 10 times what? That will be, sorry, 30 times what? 8. So that also give me 240 millimeter squared. So now the next thing we'll do is to find the total area. Okay, so I'm going to represent this with 80. Okay, that's for the total area. So I'm going to add all this. So that'll be 500 plus 240 times 2. So this gives me 980 millimeter squared. That'll be the resultant area. Okay, so now that we have the resultant area, let's locate the center of what each of these rectangles. Okay, so let's locate the center of what each of these rectangles. You can do that by drawing what a line of symmetry through each of the rectangles, and that will help us locate the center. If I want to locate the center of this first rectangle here, I can draw a line of symmetry through this rectangle. Okay, that's dividing it into two equal halves. Okay, I can divide it into left and then the right halves, and then also I can divide it upwards and then downwards. So where these two lines of symmetry meets, that will be the center for this rectangle. I can do same for this one also. I can draw a line that cuts it into two equal halves. Okay, and then I can also cut it this way. So where they meet, that will be the center. And then same for this area also. So that will be the third center. So that's how I can got the C1, the C2, and then the C3. Okay, so now since the question requires that we find the x and the y position of what the cross section is centroid, and you already know where the centroid will be since you know the line of symmetry. Let's try to do some sketch, okay, of the position. Okay, we know that it will definitely be on this line here. Okay, but it will have what an x and then the y position. So let's try to locate this centered on the axis of symmetry. So let's look at what I was talking about. So I know that what this centered have what a direction in the on the x-axis. Okay, so let's take this to be the direction on the x-axis, and then to have a direction on the y-axis. Okay, so let me take that one to also to be this. Okay, so that means that before you can locate the centroid of this aluminum channel here, you must move a certain direction in the x-axis and then a certain direction in the what in the y-axis, and that will help us what locate the centroid. And we already know that what the centroid is going to be what on the line of what symmetry for this figure here. That's how come I located it here. Okay, so what that means is that we need what the direction on the x-axis, and then sorry, the distance on the x-axis, and then the distance on the y-axis, and that will help us locate what the centroid. So I'm going to name this part. I'm going to name this part the y bar. Okay, and then I'll name this part also x bar. Okay, so those are the distance that we must move in the x and then the y axis in order to locate the centroid. So how are you going to get these distances? Okay, so let's say I have my resultant area here. Okay, this is 80. Okay, so one thing you should know is that we have our y axis to be here. Okay, so when I take the moment of what this 80 here about what the y axis, that means that what we are finding the moment of the area about what the y axis, and you know moment is what moment to be what the area times what the perpendicular distance. Okay, so when you are taking the moment about the y axis, that what the area times what the perpendicular distance from what the y axis. Okay, that will be the area times what the perpendicular distance from what the y axis. So when I have my area to be here and I'm taking the moment about what the y axis, what will be the perpendicular distance? The perpendicular distance will be the shortest distance from what the total area what to the y axis. Okay, it will be the shortest distance from the total area to the what to the y axis. So let's look at that. So I can trace this from here to here. So that will be what the shortest distance from what the total area to the y-axis, and that will be what the perpendicular distance. So that will be x bar. Okay, so that will be what x bar. So I'll say that what moment about the y-axis will be equal to what at times what x bar. Okay, so same way, if I want to find the moment about what the x-axis, okay, if I want to find the moment about what the x-axis, that will be what the shortest distance from the total area to the what the x-axis, and that will be this distance here. Okay, and that will be this distance here, and that distance is noted to be what the y bar. So the moment about the x-axis, okay, will be equal to what the total area times what the perpendicular distance, which is what the y bar. Okay, so that's what we have now. So what that has to tell us is that if I want to find the x bar, I'll have to take what the moment of what the total area about what the y-axis, and if I want to find the y bar, I must take the moment of what the total area about what the x-axis. Okay, so what you're actually doing here is that all these areas here, okay, we found a total area for it. So you are looking for a position, okay, or a location where all these areas what will be evenly distributed. Okay, we are looking for a location where all these areas will be what evenly distributed. You can think of this as the center of what gravity, where the total weight of what an object what is exerted. Okay, so the same thing that we are doing here. So you can see that what with all these areas here, okay, you want to find a location where the total area is what evenly or distributed. That's what you are doing here. Okay, so what that would mean is that instead of using this complicated system here, okay, this area 2, area 3 here, and then area 1 here, we are representing them with what a single what area, and this single area here should be able to what to perform the same effects that this area what will perform. And from the principle of moment, we know that what since the sum of this areas equals this area here, then the moment that this area here, okay, all these areas what will cause about a point should be equal to what the moment that this area will also cause about what that same point. So let's look at this. So I'll first focus on my focus will first be on the x bar. Okay, so now when I take the moment about the y-axis for each of these areas here, okay, when I take the moment about what the y-axis for each of these areas here, we are going to use this same formula here. Okay, so that will be the moment of the total area, okay, that's at times what x bar should be equal to the sum of what the moment caused by what each of this area. So I'll take this area to be area 1, and then its perpendicular distance from the y-axis should be what x1, okay, and then plus area 2, and then its perpendicular distance from the y-axis should be what distance x2, and then area 3, and then its perpendicular distance from the y-axis should be what distance x3. Okay, so now that we have this, we want to find x bar. Okay, so you can actually make x bar the subject by dividing through by what the total area 80 over 80. Okay, so I can actually cancel out this, so then I have what x bar equals the moment of what all the single area divided by what the total area. So this is what you're actually going to do. Okay, so now we have the areas here. Okay, I have A1, area 2, and then area 3, but what I don't have here is what the x values. So our main focus will be on what finding the x value. So I have my x bar to be equal to area 1, which is what 500. Okay, so 500 times what x1, we don't know the x1, so we are going to find what the x1. Okay, so let's go ahead and then find the x1. So the x1 will be the shortest distance from what the area 1 to the what, to the y axis. So it will be the shortest distance from the area 1 to the what, to the y axis. So let's locate this short distance. So this is area 1, so I'm going to move from there to the y axis. So that will be this distance, and that's half of what, this 10 that we have here. So that will be what, 5. So the distance 1 is what, 5. So that will be what, a1 times x1 will be 500 times 5. So let's see what will give it, that will give us. So that will give me 2500. So a1 x1 give me 2500. Okay, so plus a2 x2. I know that a2 is what, 240. So let's find x2. So it will be what, the shortest distance from area 2 to the what, to the y axis. So I'm going to trace that from this side here to this side. Okay, so what will be the value of that? You know, the distance from this side to this side is 30. Okay, so half of it, which will be from this end here to this part, is 15. Okay, and this distance is what, 10. So when add those two, that give us what, 25. So the x2 will be what, 25, and you know a1 to be what, 240. So you're going to multiply the two to get area 2 times what, x2. So that will be 240 times 25. So that gave me 6,000. So that gave me 6,000. So that will be 6,000. Okay, so that's plus 6,000. Okay, so now let's find for the last one, which is what, area 3 multiplied by what, the distance x3. So the distance x3 will be the shortest distance from what, area 3, okay, the center of what, this rectangle, okay, to the y-axis. So that will be the shortest distance from this area 3, this center here, to the what, to the y-axis. Okay, and measuring that, you see that from here to here is what, 15. Okay, since the full length is what, 30, so half of it is what, 15. So we add that 15 to this 10 that we have here, and that also give us what, 25. So then we are going to have what, 240 times what, 25 again, and that also give us what, 6,000. So you have what, plus what, 6,000 again. Okay, so we are going to divide all this by what, the total area, which we got to be what, 980. So that will be divided by 980. Okay, so now let's simplify this and then see what you will get. I'm going to punch all this on my calculator at once and then see the value that I'll get. So let me do this. That's 2,500 plus 6,000 plus 6,000, all divided by 980. So this actually give me x bar to be equal to 14.795 millimeters. That's the value for my x bar. So now that we found x bar, let's go ahead and then find the y bar also using the same approach. Okay, so for us to find the y bar, that means we are going to take the moment about what, the x axis. Okay, so let me go ahead and then clean the board for some space so that you can go ahead and then find for the y bar also. So we learned that finding for the y bar, we are going to take the moment about what, the x axis. Okay, so that will be the moment about the x axis, and that will be what, the total area times what, the perpendicular distance, which is what, the shortest distance from the total area to the x axis, which is what, y bar. That's times what, y bar. Okay, so you know that the moment that will be caused by this area about what, the x axis should be equal to what, the moment that all these areas will also cause about what, the x-axis. So that give me my total area times what y bar to be equal to what area 1 times what y1 plus area 2 times y2 plus area 3 times y3. And then I want to find the y bar, so I can make the total, I can divide through by the total area. Okay, divide through by the total area. Okay, and this will cancel out. So then I have my y bar here. Okay, so now what we need here is the y1, the y2, and then the y3, since we already know the areas. So how am I going to locate y1? So y1 will be the shortest distance from area 1 to the x-axis. Okay, and that shortest distance will be what? The perpendicular distance. So the shortest distance from this center here, okay, to the x-axis, that be what? The y1. And you see that what that is half of what this 50 here. Okay, you know that the total length here is 50 and half of it is what? 25. So my y1 will be what? 25. So I'm going to multiply area 1 by what? Y1. Okay, and you know area 1 is what? 500 and y1 is what? 25. So that will be 500 multiplied by 25. That'll give me 12,500. So I have my 80 to be, sorry, it's y bar rather. So I have my y bar to be equal to 12,500. 12,500. Okay, plus let's find y2 also. When you find y2, you can multiply by what? The second area. Okay, so y2 will be the shortest distance from the center here, okay, of the area 2 to the x-axis. So that will be this distance here. Okay, so what will be the value of this distance? You know this short distance will be 8 millimeters, and then the full length here will be what? 50 millimeters. But you want up to what? The middle of what? This rectangle here. Okay, you don't need what's up here. Let me make that one red. We don't need this short distance here. So you are going to take this short distance out of what? 50 millimeters. And that short distance is what? Half of this 8 millimeters, which will be what? 4 millimeters. So you subtract this red part from what? This 50 millimeters here, and that gives us this distance here to be what? 46 millimeters, because 50 minus what? 4 will give us what? 46. So y2 would be what? 46 millimeters. So I multiply the 46 millimeters by what? The second area, which is what? 240. So I then I have 240 by 46. Okay, so that give me 11,040. So that give me 11,040. So that's 11,040. Okay, so that's the moment caused by the area. Okay, so now let's find the distance y3. Okay, let's find the distance y3. Okay, I actually have to clean this before. So let me take away these lines here. Okay, so I got 11,040 for this. Okay, so I want to find what the shortest distance from this center here of area 3 here to the what? To the x-axis. Okay, you realize that that will be this small distance that we have here. Okay, that will be this distance, and that distance is what? Half of this 8 millimeters that I have here, which is what? 4 millimeters. So the next moment will be 240 times what? The distance 4 millimeters. So that will give me 960 as the moment caused by the area. So that will be plus 960. Okay, so all this divided by the total area, which is what? 980 millimeter square. Okay, so now let's evaluate this and see what you get at the end. So you can actually punch all this on your calculator. I don't have much space here, so I'll go ahead and then punch everything on the calculator. So divide by 980. So this gave me the value of what? 25 millimeters. So if you recall, you got our x bar. Okay, we got our x bar to be, I think, 14.79. Yes, we got 14.795. Okay, this is that I have here. And then we got our y bar to what, 25. So this is to tell you that before you can locate the centroid, okay, or the center of area, you must move a distance of what, 14.795 on the x-axis, and then a distance of what, 25 millimeters on the y-axis. And you realize that 25 millimeters will be what, from this point what to this point, okay, and that will be what, on the axis of what, symmetry. That's the line that cuts this figure into what, two equal halves. Okay, so you see that at the end you have what, the centroid to be what, on the line of what, symmetry. So this tells that you move a certain distance of what, let's say 14.8. Okay, I made it 14.8 because I rounded this one. Okay, it's 0.79, but I made it 0.8. Okay, so you have to move a distance of what, 14.8 on the x-axis, and then a distance of what, a distance of what, 25 millimeters on the what, on the y-axis. And you see that this will land us exactly what, on the what, axis of what, symmetry. So this is telling us that what, our total area, okay, will be somewhere here, and it will lie out on the axis of what, symmetry.